Okay, we will start now. Enough time. Okay, you all know me. I'm Jelena Dimitrijevic, and this is a lecture about the good sides, the bad sides, and maybe some unexpected factors that we should also consider in our ethical analysis. So, in this lecture, I will try to also analyze ethical aspects. So, in order to make that analysis clearer, we will also consider some scientific benefits and pitfalls of this technique. So we're going from the last things that Ursula said, of course, from some technical advantages that make CRISPR a better technique than are the others. It is incomparably cheaper. For example, if you look at zinc finger nucleosis, you need, for example, just for material, not for a toolkit, you need $5,000. And for CRISPR, for RNA, which is material with which you are working, you need just $30. So it's incomparable. And also it is quicker and it's easier to use, because in other techniques you need to be really skillful and really need to be a professional scientist in order to make things function well, but here you don't have to be professional, which is also a possible pitfall. We will see that later. Also, with earlier techniques, we can use it only on some organisms, such as mice or fruit fly, and now with CRISPR we can use it on almost every organism. You remember that from Ursula's presentation. So here I put something that we can't discuss more clear, but which will be useful if you are interested in history of CRISPR. So you can look at it later, because it's too detailed. Also, if you want to know more about the other techniques, here we have something that can help you. So here we have other methods, and also the DNA size they are able to treat. You have some key advantages and some disadvantages. You also have some information if they cleave or not cleave, what companies are cooperating with the techniques. So if you are interested in further exploration of this topic, this could be helpful to you. And now we're going to the good sides from more ethical perspective. This was just comparing to the other techniques, and now we look at some advantages that are basically related to the gene editing technique. We have a possibility now to eliminate the disease. We have a possibility to eventually eliminate disabilities, and also to make plants that are not going to have so much parasites, not have to be sick from all that things that in earlier decades we had problems with, and we can maybe wipe out pathogens, but we also must be careful about this one, because we can have some ecological consequences that maybe will not be so good. And also we can combat infertility, also in humans and in other species. And maybe most important thing that is leading to all of this is that we are improving our understanding and our knowledge of human genome, cellular system, and the disease. And now, we have to ask, how does gene editing do this? How is it combating infertility? How is it curing a disease? how is it wipe out disabilities? Well, it has some specific methods, and also most specific methods among gene editing techniques have CRISPR, which we will analyze here just to realize what is actually really new and revolutionary about this. First of all, there is broken scissors. Now we will just shortly remember of the things that Ursula talked us about, CRISPR. We have this Cas9 enzyme that is cutting, and we have RNA molecule that is showing us where to cut. But maybe the most revolutionary thing is that we don't need to cut, because when we cut, we can then DNA molecule is repairing itself, and when it's repairing itself, it can make mistakes. So when we don't cut, what is happening? This is actually a method that first exposed Weizmann in 2012. It was proposed in order to make it easier to explore how the genome works at all. Because if we just make this Cas9 enzyme stick to the place where it needs to cut, and it doesn't make a split, it blocks the transcription of the DNA molecule. So it's showing us what's happening when this gene is not working. What we are doing now, we are turning the gene off, basically, and we are looking what is happening. But when we turn it off, when we broke the scissors, we can also make it turn the gene on again. And this helps us in other method, that is epigenetic. When we apply this method of broken scissors, we can easily add, with this method, we can easily add acetyl groups, which make it possible for us to, when we add it to the histone, makes it possible to look, will a system work? If it's working, that means that that epigenetic mark really has some influence. But the problem is that if it's not working, we can never say, is it because the method is not good, or maybe it is because that epigenetic mark doesn't have influence on that specific cell or in that specific environment. And this is important because you see this Marianne Roots, she was doing gene therapies for years, and then she realized that besides concentrating on genes, she may be better concentrating on epigenetic characteristics, because that's where we have the possibility to change it and make the disease disappear. So this possibility that CRISPR is giving us to explore epigenetic characteristics that we didn't have earlier is making it really possible for us to fight diseases and disabilities on a better way than earlier. Now, we also have code cracking, because epigenetic characteristics are not the only characteristics that we doesn't know the code for. There are also enhancers, microRNA, and non-coding RNA. And enhancers and non-coding RNA are the places where are the issues that are mostly related to the diseases. So this is where CRISPR is helping us to break a code and to explore the diseases more detailed. And also with I already told you, with broken scissors, we can turn the gene off and we can turn it again. We can also do it with light. For example, you can put proteins that will be activated with the blue light. And also we can do it with other things, not just with light. and we can do it so we can turn off and turn on the gene on specific point of development, so we can see what it is actually doing. Also, we can model the disease to the stem cells. I think Ursula also mentioned that in her lecture, in first lecture. And here you can also see some illustrations of this CRISPR epigenetic process and inducible CRISPR. And now, what are the other advantages of CRISPR? How can we use it to make the benefits in a practice that is really close to us in everyday life? Well, for example, in agriculture, we can make again a great tasting tomato, because 70 years ago we were just trying to make as bigger or easier to cultivate tomatoes, so it lost on quality and it lost on taste. But now with gene editing we can come back, we can get back those good tasting tomatoes by exploring how does the genes, what is the relation between genes and taste, and we can revive it in some way. Also, we can make disease-resistant rice or even hypoallergenic eggs, because egg allergies are caused with just one component of the gene, so it is really not so complicated to edit this, but they are trying to make this in practice actually now, but they will need a couple of years. And also we can try to save the honeybees, because in last decades we have dramatic increasing in honeybees population. So the scientists are exploring that honeybees that are more clean and tend to clean their hives obsessively are less probable to have the diseases and live longer. So they are trying to explore how can we edit the genes in honeybees so that we'll all act alike and again decrease their population. And also we can edit animal genes in that way so it will reduce needs to cull the animals, and it will also reduce the suffering among the animals, so it will be better from ethical perspective. Also, we can use the gene editing for, let me see, making drugs. Okay, this is clear. And again, we can use it for the extinction. This is really unusual. And I want to ask you now, what do you think? How many species that ever lived on the Earth have extinct in percents?
I've heard that every day 3 animal species and 2 plant species go extinct.
Okay, so what do you think? How many?
100%.
Almost. It's above 99%. So almost all the species have extinct. So it's a really huge question whether we should resurrect the species or which species we should resurrect, because it will make big changes in ecosystem. Yeah, in our environment. So what they are doing currently, they're trying to resurrect woolly mammoth. Not actually resurrected, I mean, they are trying to they try to edit genes in Indian elephants, so they will make it more woolly and resistant to the cold, which is for sure good, because it is endangered species, and by making space where it can live wider, it make it more probable for that species to survive. Yeah, also they're trying to revive the heat hen and the passenger pigeon and some other species, but these are most popular. And also we have possibility to vector control to make some diseases that are related to some parts of the world disappear. For example, we also mentioned this, we can edit mosquitoes so they wouldn't bring malaria anymore, or we can make female mosquitoes infertile, but there are also problems with this because we have, you see, these side effects, because many species are eating mosquito larvae or eating or for birds, for predators like birds that are really important part of their food. So it really isn't clear how it will work in practice if we'll just wipe out all the mosquitoes. So this is also related to the gene drive. Ursula mentioned it, explained it, and we will mention it also later, but related to the human genome. And also we will have better food production. I think this is clear. We can have, well, it's already appearing, bioart, and we don't know where it's going to take us. Pretty bizarre thing. And also we can improve pets. It's already happening. You see here are koi carps from Japan, and it is really a kind of artistic discipline because they are trying to inbreed these koi carps so they will be more beautiful, bigger, more colorful, and also nowadays they're gene editing pigs so they wouldn't grow bigger than 15 kilos. And also the interesting thing they make is a glowfish pet, which is kind of goldfish that glows when you put it under the ultraviolet light, and it is forbidden in California, for example, but you can have this pet in all the others of USA states, but because they all agree it isn't dangerous because we didn't eat it, we don't eat it, but eventually it's wind up as a food because you have these glow sushi guys that make sushi rolls from it. Really bizarre and also really problematic from the law point of view, because it depends whether you will have problems with law, whether you consider it as your pet, food, or GMO. It all depends. Yeah. At the end, it all comes down to labeling. And now we have bad sides. They're the same. It's cheap, quick, easy to use, and we can use it on almost every organism. Why are these also bad sides at the same time? Because the cheapness of it makes it really affordable. Everyone can use it in their own basement, in the community laboratories, non-professionals. In USA, it even become a common practice for the people not to buy the insulin, but to buy this $150 toolkit and Escherichia coli. So they are like producing insulin by themselves because it's cheaper, and then just use it. It's just like that. Also, it's quick. It's not only quick to edit the gene, but the whole techniques is developing so quickly that we don't have time to consider all the ethical problems that are appearing. And we don't have time to consider what will it become in the future at all. So also easiness for using is problem because of biohackers. We'll talk about it now. And I also want to cite this philosopher that lived 5 centuries before Christ and said the same road leads up and down. It just depends on the direction what we will choose. I want to cite this here because this is example how the same things that can make us benefit from it are the same things that can be a pitfall. And also I want to mention that it all depends on direction that we will take, and the direction that we will choose depends on things we know now, and we don't know so much as we think. It's just like those architectural illusions on the road. For example, Temple of Svetisava, the farther you go, the bigger it looks, but when you come really close, it's something different. So we never know what the scientific invention will, how scientific invention will end up. For example, when Röntgen invented X-rays, the scientific community didn't applaud him. They all left. They told him that it is the most stupid invention and it will never make any use. Now we can hardly imagine going to dentist without this technique. And also we have example with refrigerators that at the beginning use sulfate dioxide that is really poison substance and can even cause blindness. So it was really problematic. And when Freon was invented, it was a big revolution because it wasn't dangerous for people. But then what was development and one step forward on the, this smaller level, on the global level, it was a step back. Because we nowadays know that Freon caused holes in the ozone layer, and it was forbidden in 1994, and now it's big development that we move also from that technique. So we never know where the science will take us. We must be careful. So now we're gonna go back to the do-yourself biology and talk about also advantages of it and disadvantages of it. In some way, it is really good because affordability, easiness for using, less time consuming, and cheapness makes it makes science now really democratic. So is it good because it allows us to improvise, it allows us to bring up with our creative ideas.
The education, and that is critical part.
Yeah, that is critical part. So what does it mean for us? Does it mean that this is change for better, or does it mean that we are like a step closer to the possibility of doomsday scenario? We don't know. And it is interesting that this common laboratory in USA functions so well that some of them have even developed relations with FBI. I mean, it's weird because they have so many professionals, so why would they go to some community laboratory that doesn't have any professionals, but somehow it's working. And many of them have made some great patents and some discoveries, so it's not functioning so bad. But in the end of the day, we never know where it's going to lead us, because they can also make some dangerous viruses, and it is also a question whether they're using right biosafety measures. Because if some organism that is able to have babies, I mean fertile, if some organism is fertile and it escaped from the laboratory, because of this gene drive, Ursula talked to you, you remember this is the fact that the organisms that are edited with the CRISPR technique have the possibility to transfer these characteristics more easier. It will go up to 99% rather than 50, which is case in the normal reproduction. So it will be dangerous for environment if we don't expose the right biosafety measures. And here you have some example of do-it-yourself laboratory.
Good idea.
Just in case. And now we're coming to unknown factors. And just to remind you why we're still on the road, we already mentioned that this quick development doesn't leave us with much time to think, with much time to analyze. So we must stop and make things a little bit slower. And also, the big topic for our discussion is engineering the human embryos that started in 2015. Also, we have to mention that these embryos, they are editing, were unable in giving the live birth, but even beside that, it caused big ethical discussions, and people, that's the point where the people are really start to worry. For example, you have Jennifer Doudna, which is a pioneer in using the CRISPR. And she said that before 2014, she thinks all that ethical problem, ethical discussion are for some people that don't really have anything to do in their life. But after she saw the mice that they gene editing and that is become sick of cancer, I don't remember which type, she really started to shiver and she had some trouble sleeping, and she realized how ethical questions are really important, because one day that thing that happened to mice can happen to people, and we don't know how many mistakes we can make with gene editing, and for now on it's not it wouldn't be rational to use this technique in editing the gene embryos or human embryos that can result in live birth. And also there is this whole discussion of gene drive. Where it's going to drive us, we don't know. How it's going to affect environment, we don't know. There are so many facts about this that are unpredictable and hard to analyze, so we can't know in advance. It's still an open road. We're still going to some unknown direction. But the fact that we are going to an unknown direction doesn't mean we don't have to continue, especially when we are working on just analyzing, exploring. For example, these embryos wouldn't be used for giving a live birth, so what are we discussing? We're not doing damage to anyone by just exploring. So we should keep on exploring till it's not safe enough for use, or till it's not, we don't have enough knowledge to decide that is better for using them. So it's also the fact that Savulescu mentioned that all the technologies are dangerous, all the new technologies. For example, personal computers and mobile phones were also unpredictable. In the past, we were discovering these techniques. We never know where this can lead. For example, there were arguments that this can result in easier cyber attack, which is true. It is make easier, and accessible, easier and accessible everything, so even terroristic attacks. But even though these pitfalls, these techniques are really valuable, and these benefits that they are giving us are hardly to, I don't know, how can I say?
To imagine this world without it.
Yes, no. Exactly. So now we see the case where benefits are highly above the risks that they can make, because these risks exist anyway. Even, I mean, I also forgot to mention, some people are against this pet modifying because they say it's cruel. We made it just for our pleasure, just force animals to look the way we want it. But isn't that just something we are doing for ages? Exactly. Inbreeding is happening for decades, for centuries, and it also has bad effects. For example, there are many dogs that have hip problems as a result of inbreeding, and with gene editing techniques, we can make these problems disappear. We can have some breeding, yeah, and also fix the problems that inbreeding caused. And now we are going to address some ethical issues that we already mentioned briefly, some of them, but we will focus on this problem related to human genome. For example, some of the ethical discussion were concentrated over the topic of preserving the human genome. So, what are we actually talking about here? The most problematic thing about preserving human genome is that when people are arguing that gene editing or cloning will make this human genome change or even disappear in this form we know it, is that they're forgetting that there is no some human genome that is always same and that is transferring from generation to generation. There is no such a thing. Basic condition for human genome to exist is to evolve. In order to exist, it must evolve, and that's what's happening all the time. We have evolution. So, what's really the difference? Only difference is that Darwinian, quicker. Yeah, exactly, and more rational. Because Darwinian evolution is an unrational process. It's blind-guided. It doesn't have some goal that it is directed to. And in gene editing, we have some reasons. That is process that is rationally guided. And also, you mentioned it, quicker, which is not a small advantage. Also, you can check Dawkins. He have a book, Blind Watchmaker, because you see in philosophy we talk much about this creationist argument that we wouldn't ever have this perfect, beautiful world if it was made just by chance. And Dawkins is arguing in that process is just evolution, and that our perfect watchmaker that make so harmonic world that is functioning perfectly is just blind force. I mean, this is oversimplifying the philosophical arguments that are really complicated, and the debate on this is really long, but just to illustrate it, if you want to go further on that. Also, some of them are arguing that we could change the whole human species as we know it. So it will result in some kinds of post-humans. But it is not clear why this should be a problem by itself, if this will be a better form. What are we saying? And also, there is a question, are we just victims of habit? Are we just trying to preserve this state of things because we think it's the best, because we are so inhabited on it? And we will also mention it related to the other problem, but now we will switch to, yes, preserving diversity, that is also related. Some of them argue that we shouldn't edit disability because disability is not disease, it's just characteristic that is different. And in a world where it wouldn't be disability, we will be missing some really important lesson about what diversity means and about how health is important or how we can help each other, at least. So there is a question, should we edit disability if we could in future? And there is also a question from the other side. Is the diversity value we should ought to preserve at any cost? Because if we try to preserve the diversity by avoiding to edit the disability, are we is it too expensive because we are avoiding to help the human beings that really need help? Because if we can make their lives easier, why shouldn't we do it? Why should we sacrifice them for benefits of others? I mean, the other may benefit from it because they will know how to help each other, how to prize the diversity, but still we have these individuals that will suffer. So why are we doing it? This is argument of Sparrow, and he'll also cite Kant on this, who said, you also heard that from Danilo, that we should treat every human being as a goal by itself and not just mean for something. So if we are saving disability in people, it's like we're treating them like means, not like goals by themselves. We're using them for making us more happy in more diverse world. It's not morally right. Something's wrong in it. And there's also a question, why is diversity value? Is there something about diversity that makes it value by itself? Especially moral value. And also, if we accept it like a value by itself, the genome diversity is not the only diversity there is. We already mentioned epigenetic marks that are related to genome, but that are something about it. And also we have all the social circumstances. We think we have free will at least, so we can make diversity in this world by other means, not just by disability. And also there is some thought experiment by Bostrom and Orr. They call it reversal test. That means if we are thinking whether we should go back and go in some future state of affairs, we should think. We should analyze it like this. Okay, if we are in that future state of things that we are thinking about to make a case, would we come back at these states of things? And in this case, we probably don't. And in my opinion, it will be like we are thinking to make slaves again, just to make people value freedom more. It's just like that. And also, we mentioned this, are we overvaluing current state of affairs? And there is this philosopher, David Hume, that argumented that we always value current state of affairs more because we're used to it. And he also questioned causality. You maybe remember this from high school also, because he told if we hit a billiard ball, okay, if we hit a billiard ball, we don't know it will move. We are just used to it, that it moves all the time, in all the cases in the past, but we don't know it will be the case in the future. We don't have scientific proof for that. And also he told us that maybe we see perfection in this world because we try to so hard. We have only this world, and it's not perfect, but we see it as beautiful and perfect because we are trying to enjoy it as much as we can. And maybe it's not all the things are function perfectly, and maybe there isn't maybe everything isn't useful, but we are just trying to make everything useful. So maybe that's the reason why it is. Maybe things are otherwise. Maybe they're not so perfect as we try to see them. Maybe we are just trying to get used of it. And also, we have ethical, considering human genome editing, we have a question, is it safe? And one thing that Harris is trying to explain in his paper is there is no such a thing as safe. The whole risk analysis is based on that fact. There is not anything that is absolutely safe. There is only safe enough. And what is safe enough, that is relative to the context. So we must consider risks, we must consider benefits, and see what's best for us to do. That's the only thing. And here I cite this biophysicist Juan, who said that there is a mentality that as long as it works, we don't have to understand how or why it works. And that's the problem of quick appearance of CRISPR and with quick appearance of anything in science, because we are so enthusiastic about its benefits, about its usage, that we don't question the risks and we don't think what are the problems that it might cause. So he is proposing to continue research until it is proved to be safe enough. But still, we also have some practice in medicine that are not safe enough, are not even ever tested on healthy humans. For example, treating of the cancer, which is extremely
harmful for other parts of
and
our
toxic. Yeah, so it's never tested basically, and it's approved because we don't have anything better, and they don't have much to lose in that case where treatment is needed.
So they use CRISPR to cure cancer?
Well, they hope they could, but for now we only thing that we can do is to cause it, unfortunately. But with further exploration, it probably will be possible. And also, they hope for 2 years it will be possible to do the gene therapy, with CRISPR, and with this they can, I think they can cure maybe cancer in cases of the children, or leukemia, or some diseases like that. I mean, I heard that in Tirshova they're already doing this gene therapy, but they don't do it with CRISPR for sure. I don't know how they do it, but it works in a lot of cases. So it's already an improvement. And one more ethical concern about editing the human genome is that it affects the next generations. So the problem is that would they give us consent? And the main thing is that they can't, and they don't. I mean, who asks them if they want evolution? Nobody asks us. We don't have possibility to choose. So if we already have to choose between blind process and rationally guided process, why not use rationally guided one, even though it makes some mistakes, if they're not big enough, of course. For now on, it's not safe enough for human genome. And also, here we have example of parenthood, which is obviously a case against this objection. I mean, all the parents are making decisions about with whom to have a baby, when to have the baby, and how will they look after baby, how they will grow it up, how much education or how good education it will get. So there are many decisions that future generation don't have, they don't choose it. They don't have consent about it. I mean, we have here this philosopher Parpit that called this non-identity problem, because we are worried about will of the persons that are not persons yet. We are worried about individuals that are not yet individuals. Yeah, they don't have identity yet. They don't exist. That's it. So this problem basically don't exist. But there are many discussions of this for decades. It will be probably. So one more ethical concern that we have related to this and to CRISPR, and that is not closely related to the human genome, that you already mentioned between the lines, is that whether the process is the problematic or product. Basically, product is the thing that can harm our health, so maybe it should be in the focus of consideration and regulation, but in these cases we can just turn off some genes, so we couldn't find a difference between natural products and modified products. So what is the difference? Why should we analyze the product? Maybe we should focus on process both. And most of philosophers are arguing that this is the best approach to take all the issues and analyze it. And also there is a question of solidarity here. This is also related to the human genome mapping, because this is also a question: how much of our genetic information are we willing to share? Because in some cases, obviously, others can benefit from it, and it is not clear who are the relevant others or how much they should know, how much can be harmful for us and how much could it benefit to them. And also there is a question of the right to know or not to know, because in order to make responsible reproductive decisions, we have to know what genes we are carrying. So this is also a huge ethical questions. How much information do we have to know to make some responsible decision? Because if we have some genes that we know that are harmful, should we have children? That's also ethical questions. For the end, I will cite Maria Knupert. You also already noticed this from Danilo's last lecture, that ethic doesn't give you some already formed answers, and that we don't have some magic sticks with which we can make it all perfect. Ethic is rather, does not consist of a static set of theories or principles that can unproblematically be applied to new situations. It is rather constant analysis of benefits, of risks, and of the situation. So it, especially practical ethics, depends on how much we know at this moment. So that's it. Thank you for your attention. Okay, questions?
What is bioart?
Bioart, well, that's related to the things they are trying to make. For example, they're trying to make the creature that will look like a dragon, or they're trying to make some fluorescent plants, or they're modifying plants so that they will look more artistic. And we can also mention some things that are not related for CRISPR. For example, in Netherlands, I think, but maybe I have made a mistake, maybe some other country, you can sign the contract to leave your organs for the artist to make exhibition. That's most bizarre thing, but it's really happening.
I also saw an exhibition where they had some wings. They called it pig wings, and they were just from tissue engineering. So they took pig cells and made it into the form of wings. Yeah, at first I thought, what is this? Was it some South American not thinking about what it was doing? But actually they have a big contemplation of the bioethics behind their art, so I thought it's really cool. It's an Australian group. Yeah.
Crazy Australians.
Exactly. Yeah.
What about using this method in agriculture? I mean, is it what people call GMO?
Well, yes, but not actually, because in GMO you have like in one plant you're like transferring some foreign DNA, and in these cases it's not foreign DNA, it's just changed, and you can't really say is it natural or unnatural. I mean, for some changes. For some it is obvious that are not natural because they don't resemble one to one. And in some cases where it can be also natural, it is not clear. So you can't know that by looking just at the product.
But it is modified.
Yeah.
So if you use
Yeah, and that is also problems because these agencies that are approving product can approve some product as natural and don't even know that it is modified. So that is crack to which.
Yes, so there's a big issue in the European Union also about if it's a GMO or not. But I think the reason for them to say it's not a GMO is that they actually cannot detect if it's a GMO or not. So they say, okay, if it's edited with CRISPR, it's fine. Yes, so you cannot detect it anyway, so it's just proof. Exactly.
That's why we must consider process also. But there is no exact way how. How can we know it?
So can you tell us about GMO? I mean, there's a lot of fuss going on around it. Like people don't want GMO as it's like some doomsday food.
GMO food?
Yeah.
I will have a lecture on that.
Yeah?
Later, yes.
Okay.
Yeah, if you have some specific questions, you can just send them to me or something.
Okay.
So we'll talk a lot about GMO and ecologic changes.
So, I have a question. Do you think that we as humans are still subject to the evolution? Because I think that we stopped it highly, right? I think I wouldn't be alive, like without my contact lenses, I cannot cross a street.
So
Me too.
natural selection would hit you.
Exactly, but it's not like
Or car.
I don't know, we thought something at faculty that we're not humans anymore, but rather like cyborgs or post-humans, because so much information that we use, we don't know it. It's stored elsewhere on our phones, on our computers, in our passport. We don't even think about it, and we can't survive without it. And our basic functions, we're not doing them anymore. We don't make the fire or produce our food or anything. We're just like
storing information in other
yes.
ways. So it's interesting. I didn't
Yeah,
talk about it.
like imagine a scenario where internet goes down. Some guy was making a prediction that like 5 billion people would die instantly. Because now even food supply is based on internet. If you shut down the internet, all the databases are gone. And like in like 15 or 20 years, if nobody stores this information we are using now, this will be like a black point in history. Because very little percent of stuff we know we actually store on paper. Mostly everything is online. So, and it's all somewhere in the air, you know. So if you just turn it off.
Yeah, but that's the same problem we have with books, because you can easily burn them. When Alexandria Library was burned, lots of informations were lost.
And books are damageable.
Yeah, they're also aging.
Yes.
There are also some fungus eating them, so and mice.
Microorganisms.
So they're also not so easy to.
Humans are fragile, and that is.
Yeah, that's it. So the more improved and more enhanced we become, the greater the risk that some psychopath or sociopath will come to idea to destroy it all. So it's just like that. Not just the information.
Sci-fi movies.
Yes.
So you're hearing it.
Yeah. 12 monkeys.
Yeah, but do you think that some of the diseases today are fabricated? Like there is like this conspiracy theory that AIDS was made in a laboratory. Do you think it's true?
Why not? Like computer viruses. Viruses can be produced now in laboratory.
Yes, they can. But this one is, I think it's so bad that people wouldn't be able to produce it by themselves. I think that it is much higher than brilliancy of current people.
What about pyramids? So you can't tell that.
What?
Pyramid.
Pyramids.
Pyramids. Yes. So we now think that humans could not build them in that century or.
Well,
So
that's also the question of slavery or labor, because nowadays no one will work so hard.
yes.
And at that time it was possible.
And why are people making fuss about all this, about gene editing and stuff, about enhancing people, and no one is talking about contact lenses or antibiotics or anything else that makes us live, even though by evolutionary theory we shouldn't be alive?
Yeah, that's a good question, and that is also example of how we are just used to it. We have a habit using antibiotics, and nobody's even question it.
Mm-hmm.
We just stop question it, and now the new techniques appear, and everybody's trying to see what could be wrong. Everybody's afraid. Everybody's have a little bit shiver about it. Should we accept it? It's something new. It can be harmful, and they forget about history. They forget how earlier in our society we were considering some of the some of the stuff that sounded much more dangerous, and now they're working perfectly fine.
Like
For
atomic bomb. Totally fine.
Yeah, but it's true. But at every point in history, people were asking themselves, "Are we supposed to use this?"
Yeah, and sometimes it was too early, and sometimes that was too much fuss about nothing. For example, atomic weapon, it clearly came too early for us. We weren't rationally prepared and morally prepared for that kind of stuff. So risk was too big, and we had these big catastrophes. But now, when we are more mature, it's like working okay, but we don't know. We don't know what will happen in future. It's open risk.
Maybe one of the differences could also be that gene editing can be inherited to the next generation, because contact lenses are not.
Too bad. But bacteria and gene transfer, and that is inherited. So not in humans, but in other organisms, changes we make now are inherited and have impact on human later in another generation. So that is.
Yeah. We don't know where the gene drive is driving us.
I like the example of the antibiotic, because I mean, when you take an antibiotic, what you do is to wipe out an entire population of bacteria. So how can you
So you
justify
should
that?
cry. You should cry with every pill.
And also the practice with vaccines sounded really dangerous, and it was accepted just like that. And now they are making a fuss about it again.
No, but I think there's a big point in all that about questioning everything, because if we don't question stuff, we might end up with stuff like fascism again, you know.
Yeah.
When an idea gets accepted in general public by people who don't think enough, it's bad. So I think it's important that people that study similar subjects and talk about it and see see what are the good and the bad sides. I mean, you said it yourself, it's so easy to do, and it's unpredictable, even though, I mean, when an amateur does something, I mean, I don't know anything about biology, I say again, so I'm not going to ask stupid questions. Can you make a virus that will kill us all or something? But you know, some of the best stuff come up by accident, so we will never know what that accident will be and how it will be.
Of course, some of the fossil records that changes called paleontology came up from the amateur that is working just to collect things, rocks and stuffs, and he discovered something that scientists couldn't do for ages. So it's always good to let the amateurs work, but there are also biosafety measures.
My opinion is that proper education is crucial to all things. So if we educate people, they will know more and know how to rationally make decisions about all these things.
Yeah, exactly.
And, and at the end, someone with the money, all end up all these questions because he had money.
But well, there was a big fight upon the forbidding of rayon, and at the end, scientists won. Those great companies that wouldn't want to stop producing it. So there's always something in fights of science against the big companies.
Yeah, this is also interesting that you just said that the amateurs do whatever they want, and you said that people need education. So
yes, but education doesn't have to be formal.
Yes.
It can be, we can have like a lot of informal courses, a lot of stuff on the internet. You can always educate yourself from your home if you're inquisitive enough and just move from trash information.
There is a big difference between amateur and scientists, and we should be in the middle. Most of the population should be in the middle for some things. So.
Yeah, like you can be amateur, but also be aware of risks and of some important stuff. Just to know where to look, for example. Because if you don't know where to look, if you're amateur and you find something, you wouldn't know that you find it also.
Yeah, so I mean, at least someone has to tell you, hey, be careful with this. Like, for example, with this toolkit, there should be some...
Yeah, someone have to tell you discovered America. Okay, more questions?
You have the best accent here, so you should talk.
Oh. No, I prefer to listen to them.
Do you know if next week more people will come?
My friends will, they have lectures now.
Oh, maybe.
Three girls.
Okay.
Yeah.
Okay, because maybe then we can again put it together and just like one. Like if
Three
people
girls.
also just 3 or 4 people come.
Yeah, maybe. We'll see.
Just showing demo like that.
Okay, I will turn off the camera.
No.